Today I am going to show a cat and dog image differentiator made by Google Colab. I have used this Kaggle dataset of cats versus dogs. Um, this dataset containing several dog images and a dataset containing several cat images in both test and training datasets. The first step is to import the dataset itself through these commands. Importing the zip file using now importing several important libraries like TensorFlow and Keras layers. Basically this model works upon and CNN architecture. CNN architecture basically takes the data, moves it through several layers, repeated layers, convolutional pooling, flattening those layers and giving a result. My result is based on a binary value of 0 and 1. The cat, it's a cat, shows a binary value of 0 in an array, and the dog shows a binary value of 1 in an array. So this code block actually takes the image and gives it an integral label and changes its size to 256 by 256, and we actually have two types of images, training images and validation images. Validation images actually mean testing images. This is the process of mapping the image in 255 pixels. This is the main code block of the layers, con 2D layer, max pooling layer, and we have repeated the same layer 3 times. For example, in the diagram it's repeated twice, here it's done thrice. Now, and finally flattening the layer and using densing the ReLU actually gives the image a value of 0 or 1. Sigmoid maps those zeros and ones to, in an array so that we can read it. Now the summary of the model is con 2D layer, we give it a 254 by 254 image with 32 parameters, and the second layer it reduces it to 127, then 125, and then 62, while the parameters themselves increases. Total parameters are around 14 million, and trainable this is the compilation of the actually we have the binary numbers in an array, and this is compiling that array. Now comes the actual machine learning. It does it in 10 steps. So as you can see, 32, 64, 128, 128. This actually means as you can see, these random lines, these are it's the depiction of those. These lines increases and then further decreases. This means it's training the data on lower parameters, then as the layers decrease, it increases the parameters, then reduces them. And this is the training of the itself. It was done on my graphic card itself, and then plotting the graph of the validation against the training of the data. This shows the this actually shows that the model isn't very accurate it's called it's overflowed, because of which it's not really very accurate, but those images actually show the true values. These graphs really show it's very overvalued. So basic solution is to feed it more data. Since I didn't have more data, I didn't do that. And importing, now this is just the testing of the data, importing the library cv2, plotting it, plotting our image. The color is bad because of the RGB, and testing and the dog has been assigned array of 1 and the cat has been assigned array of 0. This was the training of the testing of the model, and it's pretty accurate. Thanks.